So this video lesson is all about this application of percent problems in which we talk about percent change. And now this is not to be confused with percent conversions where we go from percent to decimal to fraction. We're back and forth between any number of those. This involves problems where what we're looking for represents a percent of change. Let's take a look at an example problem like that, and I think you'll get the idea of what we mean. So let's take a look at this problem. Martha exercises. While she exercises, her heart rate is 180 beats per minute. While she's taking a nap afterwards, her heart rate drops to 60 beats per minute. What is the percent change from her exercising heart rate to her resting heart rate? So now we have something that we know we're going to use two ratios to originally solve because we have a percent question here. But we need to think of a few different things first. We need to think of what application are we looking at? What are we looking for? We're looking for the percent. Our unknown is that percent, some x over 100. And that percent represents a change. So the question here is, how do 60 and 180 fit into these two parts of the right-hand ratio in this proportion? What is the original that we're talking about, the total, the 100%, and what is the change? How do 60 and 180 fit into this question? I'll give you a hint. 60 over 180 is not the answer, nor is 180 over 60. We are looking for a change, and none of those represent a change. Go ahead and pause the video and see if you can figure out how we can use 60 and 180 to represent a change and how that might fit into this equation. Well, the only thing that changed in this question is the number of beats per minute, from 180 to 60. So that change is 180 minus 60. It dropped by 120 beats. Now, this 120 beats represents the change from exercising to resting, so that 120 beats is related to our x. That is the change. Now, the question then is whether or not we're going to use 60 or 180 as our 100%. Now, the heart rate dropped from 180 to 60. So where we originally started talking about, that first instance of the heart rate has to do with 180 beats per minute. So our 100%, where we started from, the original amount that we're talking about is 180 beats per minute. And for any question where we look at a percent change, we always have to think to ourselves, what changes and how much does it change by? In this case, her heart rate changes, so we find out that her heart rate changes by 120 beats per minute. We're interested in that specific number. And then we are asking the question, what percent changes that from the exercising heart rate? By saying 120 is what percent change of her exercising heart rate, which is 180. 120 is what percent of 180? And so after we think about that, we can finally set up the ratio that we talked about before and get to x over 100, which is our percent, is equal to 120 over 180. 120 being the change, 180 being the original. We can simplify this down to 2/3, which we should always feel free to do. 2 times 100 is 200 divided by 3 gives us x equals 66.6%. If you're unfamiliar with how to solve this using a proportion and cross products, go ahead back and look at the cross products writing and solving proportions video lesson. But we get x is equal to 66 with a 6 repeating after the decimal point, and that represents a percent. But I want to look at something here first. We found that our ratio of change to original, 120 to 180, 2 to 3, gave us our percent. Now, 2/3 is 0.66, etc., with the 6 always repeating. And we know from our percent to decimal conversion that these two are actually the exact same amount. If you forget about that or are unfamiliar, go back and look at the percent, decimal, and fraction conversions video. But looking at this, we can see that maybe we don't have to deal with the 100 over here. 2/3 is 0.66666. If we get rid of this 100 and just let x be a decimal, multiply our percent over here by 100 to get our decimal. 2/3 is the same as the answer that we have. And we can actually do that. The percent change is just the amount of change divided by the original amount. Now this is the percent change in terms of decimals. It's not the percent change as a percent. Our amount of change over our original amount in our last example was 2/3. It wasn't 2/3 percent, it was 66.6 with a 6 repeating percent. So then looking at this as a decimal, we can see that that decimal is what we get when we take our fraction ratio, x over 100. We change this percent to a decimal by dividing, by that 100, and it gives us our x. We divide numerator and denominator by 100. X divided by 100, which is the percent number, divided by 100 is a decimal. And 100 divided by 100 is 1. So amount of change over original amount. Now this is very important. This original amount cannot be the amount that it changed to. It must be the original amount. But let's see another example of this and see what you can do with it. To drive home the point that this is percent change equals amount of change over original. And we're going to look at a school here where the enrollment in 1980 was around 400 students. This year there are 685 students. What is the percent increase in enrollment since 1980? Now I'm not going to ask you to pause the video. Feel free to if you want to go through this, but we'll go through this one more example and then I'll give you 3 questions to work on for percent change. In this case, the percent change is what is unknown, so our x is our percent change, and we're looking for the comparison of the amount of change. The amount of change is 685 minus 400. Neither 685 nor 400, they are both specific amounts at points in time. The amount of changed is what you get when you subtract them from each other over the original amount. The original amount in this case is the change from 1980, 400. What percent of 400 was increased for the school between 1980 and now? So looking at that, our change is actually 285. 285 over 400 as a decimal is 0.7125, and therefore we have 71.25%. So from 1980 to now, the school increased its enrollment by a percentage of 71 1/4. Now it's time for you to go on your own. Go ahead and pause the video here, see what you can do with questions 1 and 2. Both percent change questions, both this time questions where we know what the percent change is and we're looking for one of the other amounts, and then there's one more question after this. So let's look at question number 1. We're looking at an increase in the number of leaves on a tree during the spring. The tree began with 200 leaves. This is a good indication that this is going to be our original amount because it says began. And we know that the young tree increased by 85%. So now that we know that we have an original and a percent, we're not going to look for a way to find the change anymore because we're going to use these numbers to find the change. Again, our equation equals percent change equals the amount of change over the original. So 0.85, if you're not familiar with why that is, go ahead back to the fraction decimal percent conversion, is the amount of change, which is what we're looking for, x over 200. Solve this and we get to x equals 170. How do you solve it? You solve it by multiplying both sides by 200. And now it is just an equation that you need to solve. 200 times 0.85 is 170. Now we need to be careful. This 170 does not represent the leaves at the end of the 2-week period like we're looking for. This 170 is the change in the leaves. And so since the amount of change was 170, we can get to the final amount of leaves by taking the original, 200, and adding that change back in, plus 170. That gives us the total number of leaves, 370. That the tree has on its branches at the end of 2 weeks. 200 leaves, change of 170, the total is the sum of the two because the leaves are increasing, not decreasing. For number 2, the department store sale, the price of a designer watch dropped by 25%. The watch originally cost $140. what is the sale price? So again, we have a percentage that we're looking for, we have the original cost, and now we want to know what the change is. 0.25 for our percent change. Our change is something that we're not sure of, and the original is 140. Now, if we look at 140 times 0.25, which is how we solve this equation, multiply both sides by 140, clears the denominator. We end up with x is equal to 35. Now, the watch, if it only decreased by 25%, didn't go all the way down to $35, that would be much larger than a 25% drop. But 25 nonetheless is 35 is our change. That is our 25%. That is our x. So the amount now, because the price dropped, the actual final amount is the original price, 140, minus the change, 35, and that gives you 105 as an answer. The watch now costs, on sale, $105. This is a bit of a challenge. Go ahead and look at this. Over several years, the number of squirrels in one area of forest drops 10% every decade. That means from the beginning of the decade to the end, it dropped 10%. So whatever it is in 1980, it drops 10% to 1990. It drops 10% of the new total from 1990 into 2000, and 10% of the 2000 total from 2000 to 2010. The question is, seeing if you can solve several of these in a row. In 1980, there were 400 squirrels living in the area. What's the number of squirrels living in 2010? So let's just take 1980. In 1980, there were 400. So the percent change, which is a 10% drop, equals, which written as a decimal is 0.1, equals the amount of change over the original. Multiply both sides by 400, you get x is equal to 40. So in 1990, what we had was 400 minus 40 equals 360 squirrels. Now, over this decade, it dropped 10% again, but now it's looking at 10% of 360. Well, 0.1 equals x over 360. Multiply by 360 on both sides to solve this equation. You get 36 equals x. That brings us into 2000. In 2000, the amount of squirrels was 360 minus 36. 324. And now from 2000 to 2010, which is what we're looking for, we once again say 0.1. I'll make this in red here so we can separate it. 0.1 is equal to x, because we're not sure what the change is, over 324, because that is our new total from 2000. Multiply both sides by 324 to solve the equation and get 32.4 equals x. Now, looking at this, 32.4 is not the number of squirrels living in the area. In fact, it would be ridiculous to talk about 0.4 squirrels, but that's the change, so we have to carry it over into 2010. 324 minus 32.4 is equal to 291.6 once you go through that subtraction there. So the question is, can we really say the number of squirrels living there were 291.6? No, but we can say that they were either 291 or 292. So those are our projections that we have for the number of squirrels living in the area in 2010, assuming that each decade it drops 10% from the amount 10 years before. 10% from 1980, 10% from the new 1990, 10% from the new 2000, and 10% from the new 2010. So again, for any percent change problem, all you have to do is look at the formula. Percent of change as a decimal, very, very important, as a decimal is equal to the amount of change as a number divided by the original amount that you are changing from.